All right, welcome to your oil drop diagram homework. Let's start off with number 1. What is true for A in the diagram above? Well, if I look, each time I look at A, it goes the same distance. It goes 3 meters. And remember, we're to assume these drops occur every 1 second. And unless we're told otherwise, we're moving this way. All right, so what would be true in this case? It would be traveling at a constant velocity. Excuse me while I cough. All right, excuse me while I burp. Sorry about that. I'm eating my lunch. Number 2, what is true for B? Well, I notice if I look at B, it's also traveling a constant distance each time. Since it covers the same distance every 1 second, it is also traveling at a constant velocity. Not speeding up or slowing down. But how is A different from B? So if I look at A, every second A goes 1, 2, 3 meters. And every second B goes 1, 2, 3, 4, it goes 5 meters. So A is slower. A is slower than B. Sorry for my sloppy handwriting. You try writing with one of these things. All right, let's see what we got next. All right, now 4 is referring to the diagram above. Which of the following is true for A? Now if you look at A, first it goes 0.5, and the next time it's at 2 meters, and then it's at 4.5, and then it's at I don't know, but it's covering each second is covering a greater and a greater distance. So clearly it's not traveling at a constant velocity. Each second is going a greater distance. So in that case, it is accelerating. Now remember, accelerating means to speed up, slow down, or turn, to change your velocity. In this case, since it's going a greater distance each time, each dot is farther apart, and we're traveling this way, I can infer from that that this one is speeding up. But if I look at B, B is, first dot is here, the next dot is 1, 2, 3, 4 meters away, 1, 2, 3, 4 meters away, 1, 2, 3. It's the same distance each time. So it turns out that B is traveling at a constant velocity. Let's look at the next one. 6. What is true for diagram A, for A in the diagram above? Let's see, so A is the same A, look at it, isn't it? It starts off making small distances, and each distance gets bigger and bigger, meaning the velocity is getting a greater and greater magnitude, and that magnitude is being gained in the positive direction. So it is accelerating, and it is speeding up. But if we look at B in this case, it starts off going a great distance, and each second it goes less and less distance. So therefore it's slowing down. So it is accelerating. Accelerating doesn't just mean to speed up, it means to change your velocity, and it's slowing down. Now if both objects move to the right, which one has a negative acceleration? So remember, negative acceleration means that you are either moving, well, a negative acceleration means you're speeding up in a negative direction or slowing down in a positive direction. So let's just try this. Positive acceleration, well, the question is which one has a negative. So A is speeding up in a positive direction, that's a positive acceleration. But B is slowing down in the positive direction. So when you slow down in the positive direction, that's a negative acceleration. Let's move this a little bit. Number 9, if both objects are moving to the left. Now, in this case, they're both moving this way. If that's the case, which one has a negative acceleration? In this case, it's still B, because B is speeding up in a negative direction, whereas A is slowing down in a negative direction. So if you slow down in the negative direction or speed up in the positive direction, that's a positive acceleration. If you slow down in the positive direction or speed up in the negative direction, that's a negative acceleration. Okay, welcome to the back side of your homework. If the objects are moving from right to left, which one has a negative acceleration? Let's see. Well, A is slowing down in a positive direction. So if you're slowing down in a positive direction or speeding up in a negative direction, that would be a negative acceleration. So in this case, it's A. Number 11, how fast was the object above traveling during the first 4 seconds? Well, here we go. We have 1, 2, 3, 4 seconds. So I'm going to say as well, you know what, each second it traveled 2 meters. So I could just say, well, it traveled 2 meters each second, which gives me 2 meters per second. Or I could say 2, 4, 6, 8 divided by 4, 8 meters divided by 4 seconds. Either way, I'm going to get 2 meters per second. How fast is the object traveling during the last 4 seconds? Well, here's our last 4 seconds. Let's see, here's the last, 1, 2, 3. See, the last 4 seconds, well, let's see, the last 4 drops at least. It was going 1, 2, 3, 4, 1, 2, 3, 4. It was going 4 meters per second. So the lesson here is as the dots get farther apart, you must be going faster. Now, between the first 4 and the last 4, did the object experience a positive acceleration or a negative acceleration or neither? Well, here's what happened. It was going at 2 meters per second in a positive direction. Then it sped up to go 4 meters per second in a positive direction. So since it sped up in a positive direction, got faster in the positive direction, that would be a positive acceleration. 14. For how many seconds did the object above experience no acceleration? So if it's not accelerating, if it's no acceleration means that the dots will be the same distance apart. So here they're changing their distance. Here they're changing their distance, but here they're the same distance apart. So let's see. Well, that's like not a second. So we have 1, 2, 3, 4, 5. For 6 seconds, it experienced no acceleration at all. That doesn't mean it wasn't moving. It just means it wasn't moving any faster or slower, or a different direction. We'll treat that later. Number 15. For how many seconds was the object, did it have a positive acceleration? Well, let's see what happened here. It's slowing down in the positive direction. It was going fast and it went slower. So that's slowing down the positive direction is a negative acceleration. But speeding up in the positive direction is a positive acceleration. So notice here it's 1 meter per second, but here it's 1.5. So this is 1, 2, 3, for 4 seconds. It had a positive acceleration. And for how many seconds did it experience a negative acceleration? So it must have been slowing down in the positive direction. So we have 1 second, 2 seconds, 3 seconds, and then it stays constant. So the answer is 3 seconds. Which had a greater magnitude? So magnitude is how much acceleration are we experiencing. So let's see here. Well, in 1 second, between here and here, it dropped by 2. In 1 second here, it dropped by 1.5. In 2 seconds here, 1, 2, 3, 4, 5. In 2 seconds here, 1, 2, wait, I'm sorry. It went 1, 2, 3, 4. So the negative one has a greater magnitude. So it's slowing down at a greater rate than it is speeding up. So in this case, it would be the negative acceleration. I'm just looking for the rate of change here versus the rate of change here. And diagram at the left, which by the way is an awesome diagram I made, don't you think? Look at my stick figures. All right, so it shows a ball dropped by person A, which went, and so obviously not dropping oil, but think about we're taking pictures with, say, a strobe light, and at the same time one is thrown up by person B. Okay, using the convention that right and up are the positive directions, and that left and down are the negative directions, which is true for object A. Circle all that applies. Well, it's going a greater distance each second, so therefore it is not going at a constant speed, it is accelerating. Now, it is picking up speed in the negative direction, so that means it's having a negative acceleration. So that's one thing about gravity, is it has a negative acceleration, which is true for object B. Well, object B, if we look at it, is slowing down in the positive direction. So since it's slowing down, it has accelerated motion. Remember, accelerated doesn't just mean faster, it means to change velocity. And it's slowing down in the positive direction. So when you slow down in the positive direction, that is a negative acceleration.